So that was a pretty interesting quiz to grade. So let's just go over the questions. What is the one primary difference between combinational and sequential logic? Primary difference is that combinational has no memory. The output is a function of current state. Sequential has memory. So output is a function of current state plus some, let's just call it memory, in the form of, let's say, flip-flops or something. Now, some of you went on and said combinational is all at once, sequential is step by step. That's also not true. Some of you mentioned blocking versus non-blocking. That's only true in an always block. Outside of an always block, you can't really do sequential logic. So the next question was, given Amelia-Moore machine, which machine will have more states? Take the hint from the name. More machines have more states. When we draw a state machine, output on the arc over here, that's an input on the arc, output on the arc, means it's a Mealy machine. Output in the state, as let's call it S0, x equals 1, x equals 1 over here. This is considered a Moore output. This is a Mealy output. So Moore outputs output in the state. Mealy outputs output on the arc. So generally speaking, more machines will have more states because you need more states to define more outputs, whereas with a Mealy machine you can just draw another arc. You might also see a loop-back arc. So which state machine outputs immediately without waiting for the next state? Since a Moore machine, the output changes with the state. The output can only change with the state in a Moore machine. It's generally the Moore machine, actually it is the Moore machine, that's going to have to wait until next state to change the output, whereas the Mealy can change immediately. But you can also register a Mealy to become output the outputs more like a Moore state machine. Let me just repeat that because I just confused myself. Which state machine outputs immediately without waiting for the next state? The answer is a Moore machine. The Mealy machine. Mealy machine outputs without waiting for the next state. The Moore machine, this output is in the state, so it has to switch states in order to change the output, whereas the Mealy machine can just change it on the arc. So if a state machine diagram has both arc outputs and state outputs, what type of state machine do we consider it to be? In this case, this question was probably something that you wouldn't be able to answer. For me, I define it as a Mealy machine. So, this next question was a very interesting question as well. How do we start? The simplest approach is to take the behavioral model. Let's draw out the mux first. A mux basically takes an input A and input B, outputs it to an output C with a select signal. So when select equals 0 or 1, you could be, well, let's put A over here, B over here, and let's switch this to a 0 and a 1. Looks horrible, but you get the idea. So when select equals 0, we're going to choose A. So C is equal to A when the select signal is 0. When select signal is 1, then C is going to be equal to B. So how do we do that? Well, and this is, let's assume it's a 1-bit signal. So in here we need input A, input B, output reg C. You need the reg here because I'm going to do behavioral. So always at star begin end, and we're just going to do if select equals 1 apostrophe B 0, then C is equal to A, else C is equal to B. Notice a couple things here. The equal sign, this is comparison, this is equal. All right, set C equal to A. The star is just essentially figure it out. It's for combinational logic, and since there's no clock signal at all, which I suppose is another difference up here, you could write sequential usually has a clock, combinational never has a clock. So here's one way to write the mux. Okay. Now, the other way, which I saw a lot of people at least attempt, I think one person got it, was an assign statement. So aside from this, I think someone had an assign, and they said assign C equal to select bar and A, or select and B.